Hi, I'm Mark, and I will demonstrate how to set up the MPVS Duo and LabChart for PV recordings in small animals using the conductance method. Connect all the hardware as per the video entitled MPVS Duo Hardware Setup for the conductance method. Make sure you have installed LabChart and the PV Loop 2.6 module. Switch on the MPVS Duo by pressing on the button on the MPVS Duo keypad. Start LabChart. Close the Welcome Center, click on Setup and then Channel Settings. Reduce the number of channels to 3 and name Channel 1 Pressure, Channel 2 Magnitude/Volume, Channel 3 Phase, and then click on OK. Once the MPVS Duo has initialized and with a catheter connected, press 1 to start a new PV loop protocol, and then press 2 to select conductance. You will now be prompted to soak the catheter for 30 minutes. If the catheter has already been soaking for 30 minutes, you can then press the forward arrow to go to the calibration screen. In LabChart, if the workflow isn't visible, select the PV loop menu and select workflow. If this is grayed out, check that the Enable PV Loop Workflow item is checked under the Workflow Mode menu item in the PV Loop menu. This will open the workflow window on the left. First select the workflow. In this case, it's MPVS Duo Small Animal Conductance. Next, select the channels in LabChart designated for pressure, magnitude, and phase. These should correspond to the channels connected to the MPVS Duo unit. Once all selected, a green checkmark will appear next to the Setup PV Loop item in the workflow. Now go to the next item in the workflow list, namely Duo Channel Calibration. Select the type of catheter you'll be using. The list allows for mouse, rat, or manual. Manual is used if you want to enter values from scratch. In this example, I'll use the rat catheter. It is suggested to use actual voltage values from the MPVS Duo, as there could be variation between systems. To do this, start LabChart. Then on the Duo, press 1 to go to the low voltages screen. Next, press 0 to output this to LabChart. Record for a couple of seconds. Press the left arrow on the Duo to go back to the calibration screen. Next, press 2 to go to the high voltages screen. Again, press 0 to output this to LabChart. Then the left arrow again to go back to the calibration screen. Stop the recording in LabChart. Now for the pressure channel, select the region of LabChart just before and then just after, where you can see where the data jumped when the high calibration data was recorded. Add these to the pressure calibration boxes, one for 0 mm of mercury and one for 100 mm of mercury, as demonstrated here. Repeat this for the remaining 2 channels. Do not forget to check the Apply Calibration checkbox for each. All 3 channels are now calibrated. Start LabChart and then on the Duo, press the forward arrow to move to the Balance Pressure screen. Next, press on 1 to balance the pressure sensor in the PV catheter. Press 1 to zero the pressure. The current reading on the Duo should drop to 0, as it does in LabChart. Stop LabChart. Now press the back arrow on the Duo to go back to the Balance Pressure Sensor screen. Next, press the forward arrow to move to the Experiment screen, where you can also use phase for positioning. Introduce the catheter into the ventricle. For small animal catheters, only one segment selection is available, so this does not need to be changed. A low-pass filter can also be switched on or off in the screen by pressing 5. Next, in LabChart, move to the sampling section of the workflow. Click on Start Sampling. Once the catheter position is optimal, with phase and magnitude being within the specified range as shown in the manual, the experiment protocol can be followed to record baseline, saline bolus for parallel conductance, occlusion, and finally cuvette data. Once the experiment has been completed, stop recording and check the box for sampling complete in the sampling section of the PV workflow. Now the data is ready to be calibrated for volume using the cuvette calibration section of the PV workflow. Then parallel conductance can be calculated using the saline calibration section of the PV loop workflow. Also, alpha calibration can be performed if you have an independent measurement of cardiac output or stroke volume. Finally, the data can be analyzed using the analysis section. Adjust the detector settings and analyze your baseline and occlusion data.